So as I look at this series to think about a test for convergence, I see this factorial, and that's a clue to think try ratio test. So for the ratio test, we've got the limit as n goes to infinity. Typically we do absolute value, but I can see that these are always going to be positive from 1 to infinity, so I'm going to take the n plus 1 term. So that's going to end up being 9 to the n plus 1 plus 1. And then over n plus 1 factorial, and then I'm going to divide that by the nth term, but I'm going to go ahead and just multiply by the reciprocal of the nth term because that's what happens when I do the division. So now as I look at that and see what I can do to simplify this, I see that this is, I'm going to write it as 9 to the n plus 1 and then 9 to the 1 using rules of exponents, and then the n factorial, I'll leave it n factorial, and the n plus 1 factorial is n plus 1 multiplied by n on down, and then I have 9 to the n plus 1. I left off the limit as n goes to infinity. We want that still on there. And now I'm going to cancel what I can, and I see that these 9 to the n plus 1s cancel and the n factorials cancel, and so I have the limit as n goes to infinity of 9 over n plus 1. Now as I look at that, I have a fixed numerator, denominator becoming larger, and so that limit is 0. So now I want to think of what that tells me in terms of the ratio test, and the ratio test basically says if this limit is finite and it is less than 1, which it is, then I have convergence of this series. So by the ratio test, this series converges.